Money does not have limits. Don't let the numbers limit your imagination. Welcome to materiaLuxic. Have you ever imagined living in a building without ever stepping out of it? You can find all the facilities you need, such as shopping malls in the building, entertainment venues, eating, sports, or even natural sceneries inside the building. Today we're going to cover the topic of Exceed 4000, a Japanese building project that will make you shocked. Humans live in societies under the same roof. Like, literally, the same roof. Inside of a building? A giant building. If not, then maybe you should try watching more sci-fi movies to become more imaginatively creative. But if your answer is yes, then you must know that the possibility of it happening is quite big. Don't believe us? Then you should take a look at the Exceed 4000 building. A humongous pyramid-shaped building that's designed to house thousands of people. So in this video, we will be discussing the biggest, most massive idea humanity has ever come up with, the Exceed 4000. The Exceed 4000 was a hypothetical ultra-high-rise building known as a megatall. Martin Pascoe was the one who came up with the concept and worked on it in the beginning. Its intended height of 4 kilometers, that's 2.5 miles, the width of 6 kilometers, that's 3.7 miles, and capacity of 800 floors could house between 500,000 and 1 million people. Over 3,100,000 tons of steel would go into the construction of this infrastructure. In 1997, the Taisei Corporation came up with the concept of creating a future setting for the city of Tokyo, Japan, that would combine living in an ultra-modern and technological environment with a connection with wildlife and nature. Maglev trains are the most likely candidates for use as a mode of internal transit within the Exceed, thanks to their high speed and reliant share as well as full state-of-the-art technology to use in the futuristic city. The Exceed 4000 was never intended to be developed, as the saying goes. This is according to Georges Binder, who serves as the managing director of Buildings and Data, a company that creates data banks or buildings all around the world. Acquiring some recognition for the company was one of the goals of the plan, and it was successful in achieving that goal. The Exceed 4000, in contrast to traditional skyscrapers, would need to proactively shield its inhabitants from significant variations in both the internal and external air pressures, as well as in the weather, in order to maintain its habitability. This is because its massive elevation would cause three variations. Solar electricity is required to sustain the internal environmental conditions because of the way that it was designed. The Exceed 4000 would be susceptible to natural disasters like earthquakes and tsunamis if it were built at the proposed location, which is in the Pacific Ring of Fire, the region of the world with the highest concentration of active volcanoes. The actual Mount Fuji is on land and is 3,776 meters high, which makes it 224 meters shorter than the Exceed 4000. One of the other major design features of this building is its shape, which is shaped like Mount Fuji, and its location, which is based on the ocean. At a proposed height of 2,004 meters, the Exceed 4000 will be approximately 2 times as tall as the Shimizu Megacity Pyramid. That's 6,575 feet. The Shimizu Megacity Pyramid, which was first proposed in 2007 and is also planned for Tokyo, Japan, is up against the majority of the same challenges as the Exceed. The Ultima Tower in San Francisco, which stands 3,218 meters tall, the Dubai City Tower, which stands 2,400 meters tall, and the Bionic Tower, which stands 1,228 meters tall, in either Hong Kong or Shanghai, are all potential candidates for a spot in the top 5 tallest man-made structures. The Exceed 4000 is a futuristic concept building that is designed to tower 4,000 meters above the Tokyo skyline. It has the appearance of the cover of a science fiction novel. Taisei Corporation came up with the idea for the futuristic skyscraper, also known as the Sky Penetrator, in the middle of the 1990s. It combines ultra-modern living with emerging transport methods and interaction with nature, and it has the capacity to house up to 1 million people. It is a building that exemplifies the engineering community's aspirations for the evolution of humankind and the world in which we live in the future. Our historically dispersed geographical existence is shifting into highly concentrated areas as a result of the continued growth of the world's population. An ever-increasing percentage of people are choosing to live in urban centers as a result of this trend. Because of the high demand for space in these areas, larger buildings are being constructed so that significantly more people can be housed, entertained, and provided for than these city areas were ever intended to support. Exceed 4000 is essentially an independent city that is contained within a single structure. An eco-utopian environment that is 4 kilometers high and has over 800 floors arranged in the open framework of a concave cone shape, visually resembling Mount Fuji, because residential, commercial, and public spaces are all included within the building. Its inhabitants are never required to leave. Because of the height of the building, careful management of the differences in air pressure that can be found throughout the structure is required in order to reduce the risk of altitude sickness. Distributed generators of renewable energy would be dispersed across the entirety of the building to fulfill the majority of the structure's electrical needs, while simultaneously lowering the overall weight of the power cables. The base has a diameter of 6 kilometers, so that it can support the enormous weight, and the concave cone provides the structure with stability as it rises higher into the air. The open structure of the tower makes it possible for some air to flow around the building's perimeter. This reduces the load that is placed on the foundations and lower levels, and it also creates a channel through which natural light can enter the building. It is highly unlikely that the Exceed 4000 will ever be constructed, despite the fact that it holds the record for being the largest building that has ever been fully designed. What it does provide, on the other hand, is the show that innovations got no limits. As long as we drive them forward, we can achieve great and unimaginable results. For example, did anyone in the 80s ever imagine that people in the future will be using a light rectangle called a phone? Combining advanced numerical simulations with the ability to rapidly generate and evaluate design models has allowed for the rapid evolution of engineering structures and the materials that are used to create them. This has been made possible by advancements in design technology, modeling, and simulation, which have eliminated the historically necessary need for extensive prototyping. Because the world is changing and we are looking for new ways to inhabit the planet, we are beginning to realize that everything we put into, take out of, or change on the Earth has the potential to have far-reaching effects, and no decision regarding infrastructure should be made without appropriate and thorough consideration. Consequently, we should not make any hasty decisions regarding infrastructure. So far, there have been only 14 buildings that are taller than the tallest building that existed when I was born, and another 16 of these buildings are currently under construction. The Jeddah Tower, which was formerly known as the Kingdom Tower, will reach a height of over 1 kilometer once it is finished. This raises the question of how large of a structure we are capable of and willing to construct. As for its work progress, the teams are still working on it. There weren't many details about the progress, except that it will take a good amount of time and effort to only finish its base, which makes you wonder, how much of a gargantuan is this building? However, this project has its own pros and cons, and on the negative side of it, it is simple to ignore the significance of geology in any and all infrastructure projects due to the fact that it is frequently concealed from view. The subsurface may be directly impacted by the mechanical means such as supporting foundations, excavations, or tunnels, or indirectly by alteration to the water table or contamination of groundwater. Indirectly, the subsurface may be impacted when the water table is shifted or when groundwater is contaminated. Geology is a difficult subject because there is a great many variables that need to be managed in parallel in order to obtain a more complete picture of the conditions below the surface. This makes geology a complicated subject. The first step in addressing the risks of any project and formulating appropriate measures to minimize the impact it will have is to gain an understanding of these variables and the ability to put them into context. It's obvious, however, that Leapfrog Works provides an ideal platform to collate these geological variables in order to put them into context, visualize and communicate their significance, and provide the necessary inputs for numerical analysis. As we continue to build bigger, taller, and more massive buildings, our potential impact on the environment also grows. Through the diligence of the geoscience community, armed with the knowledge and tools to make a difference, we can ensure that these megastructures of the future tread lightly. In the end, we see that we as humans have gotten more advanced than we give ourselves credit for. And it's quite comforting seeing almost a lot of people agreeing with the idea that making these buildings will help in the housing and environmental crisis. Thanks for watching. We hope to see you soon with a brand new video and a fresh topic. Don't forget to leave a like and subscribe to our channel, materiaLuxic. We will always bring you new topics about money.